Hello everyone. So moving on to the next chapter, that is chapter 9, that is hydrogen. Okay, very simple chapter, as you all know about hydrogen, isn't it? It is the simplest. Hydrogen has got a simplest atomic structure among all the elements in the nature. You know that, isn't it? It has got only one proton and one electron. Simple hydrogen has got no neutron, isn't it? And it exists as diatomic molecule. And normally we used to write hydrogen as what? H2. Okay, so we know that the hydrogen is the most abundant element in the universe and the third most abundant on the surface of the globe. Okay, and we all know that now the hydrogen fuel is so more important, that it is coming as one of the major future source of energy, that is hydrogen fuel. Okay, so that is what about the hydrogen. And when you talk about the position of hydrogen in the 10th standard, you have come across with the position as a debate in the position of hydrogen as in the periodic table. Where will you put this hydrogen in the periodic table? You have studied that, you know, hydrogen is the first element in the periodic table, isn't it? But it has got an electronic configuration of 1s1, isn't it? 1s1, correct? 1s1. It has got an electronic configuration of 1s1, but it resembles two ways. That is, one, it resembles the first group elements, that is alkali metals, correct? Alkali metals. And the second resemblance is that of this fluorine, chlorine, bromine, hydrogen, fluorine, chlorine, bromine, that is halogens. So the second resemblance is with halogens and the first resemblance is with what? Alkali metals. You know, alkali metals is also what? The outer electronic configuration of alkali metal is ns1, and that of hydrogen is ns2 np5. Okay, so one electron here to lose the electropositivity, and here one electron to gain to form that octet. Okay, so it resembles both the alkali metals as well as the halogen table. Okay, the halogen elements. Okay, now why it resembles alkali metals? Because you know, hydrogen can lose one. We know alkali metals are electropositive in nature and it loses one electron easily, very easily, isn't it? So it loses one electron to form a unipositive ion. For example, in alkali metals we know Na plus, K plus, Li plus, etc. That is unipositive. In the same way, hydrogen can also form what? H plus. You know that proton, isn't it? So in that way it resembles the alkali metals. And also the second resemblance with the alkali metal is what? It forms oxides, isn't it? Hydrogen forms oxides with oxygen. Oxides means oxygen, right? So hydrogen forms oxides with oxides, then halides and sulfides. That means oxides means H2O, halides means HX, and sulfides means H2S. Okay, so this is the resemblance. Like what? Like you can say Na2O, that is alkali metal oxide, then NaCl, that is NaX, that is resemblance with HX, and Na2S, that is sulfide, resemblance with sulfide. So these two resemblance are with alkali metals for the hydrogen atom. That is why we can debate on that hydrogen can be put in the first group element. Okay, but at the same time there is a resemblance with the halogen family also, because halogen family what? It needs one electron to complete the octet, so the valency is 1, isn't it? So there is both the probability that the hydrogen can be put in the first group element as well as the hydrogen can be put in the 17th group element, isn't it? This is the first group element and this is the 17th group element. Okay, so but now coming about the halogens, you know, normally halogens forms diatomic in nature, like fluorine, chlorine, bromine, iodine. It exists as diatomic molecules. In the same way, hydrogen also exists as diatomic molecules. Correct? isn't it? And hydrogen combines with almost all elements to form hydrides. That is again the possibility, that is the resemblance with the halogens. And also it forms a large number of covalent compounds. All these things we have studied in the 10th standard. There is a why hydrogen can be put in the first group element or in the 17th group element. Okay, so but one more thing to emphasize at this point of time is, you know that when we talk about the ionization enthalpy or the ionization potential, you know what is ionization enthalpy? The energy required to remove the most loosely bound electron from a gaseous neutral atom, isn't it? So when you compare the ionization energy of hydrogen with the group 1 and group 17, for example, if I write the delta Hi ionization of lithium, it will be in and around 520 kilojoule per mole. Okay, and if I say the ionization enthalpy of halogen means, if you take a particular example as a fluorine, okay, that is, it comes to be around 1680 kilojoule per mole. Okay, but when you talk about hydrogen, this hydrogen, the delta I of hydrogen is come to be in and around 1312 kilojoule per mole. See the comparison. So in what way this is compared? That means it has greater comparison with the halogen than with the first group element. So when we say ionization enthalpy, the ionization enthalpy is almost similar for hydrogen as well as halogens. So for halogens there are more to talk about, isn't it? So halogens, what it exists is diatomic molecule, isn't it? It exists as diatomic molecules. Then the ionization enthalpy of hydrogen is somewhat near to the ionization enthalpy of halogens. Then it forms or it reacts with almost all the elements to form the hydrides, isn't it? Hydrides. And one more is that it forms a numerous covalent compounds. So all these makes us to put the hydrogen in the 17th group. But all this criteria of having unipositive ions, electropositivity, or the compound formations with oxides, halides and sulfates makes the hydrogen to put it in a group 1. But having said that, in spite of all this, similarities of hydrogen to a certain extent, both with alkali metals as well as in the halogen family, it differs a lot of things. It differs in or it differs from them as well. Correct. So hydrogen. So what about the difference between the hydrogen of alkali and halogen is that when you compare, or when you say the radius of this atomic hydrogen, or the radius, when you talk about the radius, when the hydrogen, if it lose an electron to form a proton, you know, the loss of electron from a hydrogen atom to a proton, the radius is very, very, very small compared with the hydrogen atom. That is the reason why the H plus ion does not exist independently. It always combines in aqueous solution to form the hydronium ion. You are remembering this? It forms hydronium ion. Correct. So this is somewhat an introduction of hydrogen. Because you already said, or you have already studied, that the hydrogen can be a resemblance with the group 1, that is alkali metals, and also with the halogen metals. Yes, there are some resemblance, but in spite of all that resemblance, the hydrogen differs from these two groups in so much factors. Okay, so it is better to say that we can give a special position at the center, not in the first group or in the 17th group. You can take a position in the, if you see the long form periodic table, the modern periodic table, the hydrogen is put in as a separate table in the center. Okay, so that is why we can say there is no fixed position for hydrogen. Correct. So that is about the introduction of hydrogen. Okay, now we will mainly focus on the hydrogen, that is the dihydrogen. Okay, you know the hydrogen is the most abundant element in the universe. That means 70% of the total mass of universe is hydrogen. And also the principal element in the solar atmosphere. You know that, isn't it? The solar atmosphere, the most abundant of the principal element is hydrogen. Okay, and you know in the planets like Jupiter and Saturn, it mostly consists of hydrogen. Correct. So many importance of hydrogen is there. And one more important of hydrogen is the isotopes of hydrogen. You know what are isotopes? Isotopes means same atomic number but different mass number. Now there are three isotopes of hydrogen. That is, one is protonium, then second is deuterium, isn't it? 1H1, 1H2, sorry, here it is, sorry, really sorry. 1H1, 1H2, deuterium, and tritium, that is 1H3. So first is protonium, or you can say it is protium. Then this is deuterium. Deuterium is also named as heavy hydrogen, and the third is tritium. Okay, so these are the three isotopes of hydrogen. Okay, now you know how an isotope is differ, you know, same atomic number but different mass number. Now where the difference in mass number, where it can be the difference. So the isotopes differs in the number of neutrons, isn't it? The isotopes differ only in the number of neutrons. See, number of neutrons. Here 1H2. Here what happens in protonium or simple hydrogen, there is no neutron. There is only one proton and one electron. See, in this case, in deuterium, it will have one neutron, and in tritium it will have two neutrons. So the difference in the neutrons will make the isotopes, isn't it? So the same difference in mass number. The difference in the neutrons will give you the difference in the mass number. So that is why we termed it as isotopes. Clear? So this is protonium, this is deuterium or heavy hydrogen, and this is tritium. Clear? Okay. So this is about the isotopes of hydrogen. Okay. Now tritium, you know, tritium is one which is radioactive. What is it? The tritium is an isotope of hydrogen which is having radioactive, and the T-half, the half-life period of tritium is only 12 years. Okay. So this is about the isotopes of hydrogen. So is it clear? So now you know what is hydrogen and what are the isotopes of hydrogen. Okay. Now we will move on to the preparation of hydrogen. Okay, how the hydrogen can be prepared. The hydrogen can be prepared in so many methods, you know. In so many methods you can prepare hydrogen. That is, first we will talk about the lab preparation for hydrogen. What is it? Lab preparation for hydrogen. So, the hydrogen can be prepared commercially also. Okay, now first we will see about the lab preparation of hydrogen. Okay, how will you or how hydrogen can be prepared in the laboratory. Okay, so first we will move on to the lab preparation of hydrogen. Okay, so in the lab preparation we can say, you know, you have studied in smaller classes, hydrogen can be obtained from the reaction, the generic reaction between a metal, isn't it? Metal and an acid or a base. Are you remembering it? Metal with an acid or a base will give you salt plus hydrogen. In the 10th standard you have studied. So that is the lab preparation for hydrogen. Okay, it's very simple. You have studied a metal on reaction with acid or base will give you salt and hydrogen. For example, if you take zinc granules and dilute HCl, okay, zinc granules and dilute HCl, you will get zinc chloride plus hydrogen. See, zinc chloride plus hydrogen. So this is an acid, isn't it? This is an acid. Now if you say base, you can always say base. For example, NaOH, the same reaction you have studied in 10th standard. You have to just warm this reaction. Okay, by the reaction you will get the salt as sodium zincate. Are you remembering? Na2ZnO2 plus again hydrogen. See, So this is the lab preparation of hydrogen. In the lab you can prepare in this way, that is a metal and an acid will give you a hydrogen. Correct? Okay, so any metal you can take, the reactive metals you can take. Okay, now the next preparation is, as I said, is the commercial preparation. That means you want a hydrogen in more volume. Okay, so commercial preparation of hydrogen, that is the next preparation. The commercial preparation means in a large volume if you want to prepare hydrogen. Now what is the steps or what are the methods of preparation of commercial preparation? Okay, so in commercial preparation, the first you have already studied, what is it? That is the electrolysis of water, isn't it? So first is the electrolysis of water. If you want to say, you can say acidified water. Why I said acidified water? Because in 10th standard you have studied, while doing the electrolysis of water, you have to pour a small 2 to 3 drops of water, 2 to 3 drops of concentrated sulfuric acid. The reason we said was to make the water more conductive, isn't it? To make more conductivity, you will add 2 to 3 drops of sulfuric acid. So by the electrolysis of water using, by acidified water, if you want, you can use platinum as a catalyst. Okay, so if I say, or if I write the equation as this water and electrolysis, okay, electrolysis, and if you take platinum as a catalyst, you will get hydrogen plus oxygen. See, hydrogen plus oxygen. So this reaction or this preparation you have studied. Okay. Now the second preparation is, if you want to obtain hydrogen of having 99.95% purity, that means it is so pure, or if you want to prepare very pure hydrogen, that's the main thing. If you want to prepare very pure hydrogen, that is greater than 99.9% of purity, it can be obtained by again the electrolysis of barium hydroxide. See, aqueous barium hydroxide on electrolysis. Electrolysis means under the electricity, what you will get? You will get hydrogen, very pure hydrogen. Okay, here also, no, it is not platinum as a catalyst. Here you will use nickel as a catalyst. So, if a question is asked how very pure hydrogen can be obtained, then you can write this equation as that barium hydroxide, aqueous barium hydroxide on electrolysis, you will get hydrogen which is of high purity, that is greater than 99.95% purity. Clear? Okay. Now, again you have studied one more for the preparation of hydrogen, that is, are you remembering the reaction or the process called as chlor-alkali process? Chlor-alkali process. You are remembering chlor-alkali process? That means brine water, that is aqueous NaCl, isn't it? Aqueous NaCl on electrolysis. What happens? Aqueous electrolysis, you get what? Sodium hydroxide plus hydrogen plus chlorine. Are you remembering this? Hydrogen is a gas, chlorine is a gas, and NaOH is in aqueous. So when brine water is electrolyzed, or brine water means aqueous solution of sodium chloride is electrolyzed, you will get hydrogen at the cathode, chlorine at the anode, and NaOH solution. Are you remembering? Okay. So this is the very simple third preparation of hydrogen. Okay. Now a new preparation for you, that is about how a hydrogen can be prepared. One more preparation is, that is the reaction of steam on hydrocarbon. That means you know hydrocarbon, isn't it? Hydrocarbon means what? Alkanes and alkynes, out of which alkanes you have to undergo this reaction. If I say alkane, I can write the general equation as CnH2n plus 2, isn't it? Am I right? Okay. So, on the reaction of steam on hydrocarbon, steam means what? Steam we can write as water in the gaseous state. Or you can always write, if you don't want to write gaseous, you can write here steam. So, on the reaction of steam with the hydrocarbon, okay, or coke at high temperature. In presence of a catalyst, you can yield what? You can yield hydrogen. Okay, so there here also there is a presence of catalyst there. The most probably the catalyst will be Ni, nickel, and remember, if nickel is used as a catalyst, the high temperature must be provided, that is 1270 Kelvin is provided. Okay, so what is the fourth preparation? That is the hydrocarbon on treatment with steam using nickel or any catalyst with high temperature, you will get a good yield of hydrogen. Okay, now in this case, if I want to have a general equation for this, if I want to give a general equation, see, CnH2n plus 2 is a hydrocarbon, correct? Now plus the steam, that is water in the gaseous state, will give you, this is a general equation, that is you will get NCO plus 2n plus 1, see, NCO plus 2n plus 1 hydrogen. Here it is 1270 Kelvin and nickel is used as a catalyst. See what happens. This is a general formula. You take N is equal to 1. N is equal to 1 means what? C 2 into 1 2, 2 plus 2 4, that is CH4. Correct. CH4. Okay, CH4. Can you see it? CH4. Okay, CH4. So CH4 plus N is equal to 1, correct? So 1 is 1 H2O will give you nickel at 1270 Kelvin. So N is equal to 1 CO plus N is equal to 1. So 2 into 1 2, that is 3 hydrogen. See? So this is the general equation. Okay, this is the general equation for this reaction. That is hydrocarbon on treating with the coke. Clear? Okay. So by this method hydrogen can be prepared. Okay. Now in this method, or if you talk about this method, we can say the mixture, what you please see to the mixture, what is the mixture you are getting? It is a mixture of carbon monoxide and hydrogen. See? And this mixture of carbon monoxide and hydrogen is called as water gas. See, so what can be asked as what is water gas? So you can say the mixture, that is carbon monoxide and hydrogen, is called as a water gas. Or another question, how a water gas is synthesized? You can say when hydrocarbon on treating with the steam, you have to here clarify it as steam or in the gaseous state. Okay, so this is water gas. This water gas is also called as syngas. Why? The water gas is also called as syngas. Syngas is nothing but synthesis gas. Now, why this mixture of carbon monoxide and hydrogen is called as syngas? Why? Because syngas means synthesis gas. Synthesis gas because this mixture, that is the carbon monoxide and hydrogen mixture, is used in the synthesis of methanol and a number of hydrocarbons. See, it is used in the synthesis of methanol and also a number of hydrocarbons. So that is the reason why it is called as synthesis gas or syngas. So clear why it is called as syngas or synthesis gas? Okay. So how synthesis gas is prepared? It is prepared from the steam with the hydrocarbon. So is it clear? Okay. Now again, one more preparation for the syngas is you can prepare the syngas again by one more preparation, that is the syngas can be prepared by carbon, that is coke. Okay, the coke, that is from coal. If the syngas is prepared from coal, that is carbon, with the steam, that is CH2 on the gaseous, you will get what? You will get carbon monoxide plus hydrogen. See, and this is called as syngas or synthesis gas. So if this syngas is prepared from coal, That process is called as cold gasification process. See, now what is cold gasification process? Cold gasification process is the production of syngas from coal. That is coal on treatment with or in the reaction with the steam. Isn't it? The reaction with the steam, then you can have this syngas or synthesis gas. Correct? Okay. Now, see, you got carbon dioxide and hydrogen as the syngas. Okay, carbon dioxide and hydrogen as the syngas. Now, this production of this hydrogen can be increased by reacting carbon monoxide of this syngas as well as with steam in presence of iron chromate as a catalyst. See, again a reaction. That means, see, if this carbon monoxide, again a reaction, that is carbon monoxide, that is the carbon monoxide which is taken from the syngas, when it is reacted with the steam, see, when it is reacted with the steam, you will get carbon dioxide plus hydrogen. See, again the formation of hydrogen is there. And this is done with a catalyst, that is iron chromate. Iron chromate, Fe2Cr2, FeCr2O3, that is iron chromate and 673 Kelvin as a catalyst, you will again get a good yield of hydrogen. So, and this process is called as water gas shift reaction. Now, what is this process called? This process of making the hydrogen more easily, that is called as water gas shift reaction. See, so one more reaction for the production of hydrogen, that is water gas shift reaction. Now, what is water gas shift reaction? That is when this carbon monoxide and water in the form of steam is reacted at 673 Kelvin and catalyst, namely iron chromate. So 673 Kelvin and iron chromate as a catalyst, we will get carbon dioxide plus hydrogen. So this is again called as a water gas shift reaction. Okay, so this much is about the preparation of dihydrogen. So is it clear? Okay, so there is both lab preparation as well as commercial preparation of dihydrogen. Okay, now coming on to the physical property, you know, that is hydrogen is a colorless, odorless, tasteless, and it is also a combustible gas, isn't it? And it is lighter than air and it is insoluble in water. Now we will see one by one the chemical properties of hydrogen. Okay, physical property you know. First, now we will see the chemical properties of hydrogen one by one. Okay. Now, you know, as we have studied that the dissociation enthalpy means the bond breaking of this hydrogen and hydrogen. This dissociation enthalpy of hydrogen is very high. Okay, so because it is very difficult to break this bond between this hydrogen atom. Now, mainly as far as chemical properties or chemical reactions of hydrogen is combined, there can be three possibilities in this. The first possibility is the loss of one electron. There is only one electron, right? The loss of one electron to form an H plus ion, correct? Then the gain of one electron, okay? Gain of one electron to form an H minus ion or a hydride ion. And the third category is sharing of electrons. Sharing of electrons to form covalent bond. See? So mainly there are three possibilities for this chemical reactions to happen in hydrogen. The first possibility is it can lose one electron to form a positive or a proton. Then it can gain one electron to form an H minus ion. So the reactions can come by that side. And again the third is sharing of electrons to form a covalent bond. That means only a single covalent bond can happen. Okay. So now we will go on to the chemistry, the chemical reactions of this dihydrogen. We namely call it as dihydrogen H2. Dihydrogen in these reactions. The first reaction, see, the first reaction is the reaction with the halogen. See, the first reaction is the reaction with the halogen. Halogen means what? Fluorine, chlorine, bromine, iodine. Okay. So what is the first reaction? You know, hydrogen plus any halogen, that is fluorine, chlorine, bromine, iodine, to give HX or hydrogen halide. So if it is balanced, it is HX. Okay. Now, while the reaction with the fluorine, see, reaction with fluorine occurs even in dark, because you know fluorine is highly reactive in nature. But at the same time, if reaction has to happen at iodine, it needs a catalyst also. See the variation in this reaction. If fluorine is the halogen, the reaction even in the dark condition, the reaction happens. But at the same time, for the halogen iodine, it needs a catalyst. So that is the variability of this reaction. So the first reaction, it forms hydrogen halide. Isn't it simple? It forms hydrogen halide. Okay. Now, if you want, you can have all the examples, X being fluorine, chlorine, bromine, iodine. So make use of all these elements in halogen X and give the product. Now, the second reaction is with oxygen. What will be the reaction with the hydrogen and oxygen? What will be the reaction? Nothing but water. Is it? If it is catalyst or heating, it reacts with, and the reaction is exothermic. Exothermic means delta H will be negative. That is exothermic. If delta H is positive, it is called as endothermic. If delta H is negative, it is called as exothermic. Correct. So negative means exo. That is, heat is given out. Endo means you should give heat to happen this reaction. Okay. So normally, if this reaction has to happen, what will be it? It will give out heat energy. Okay. So that is it. Then the third reaction is the reaction with the nitrogen. So the third reaction with the nitrogen. Now what is the reaction? The reaction is when hydrogen reacts with nitrogen to form ammonia, that is NH3. So it will be H6, so 3H2. So 3H2 plus N2 will give you NH3. And here also the reaction is exothermic. That is, exothermic means what? The reaction, which value is negative. For example, if I say minus 92.6 kilojoule per mole. See, this is the meaning of delta H negative. Clear? Okay. So there is one name for this process, the reaction with the hydrogen, that is called as Haber's process. Now what is Haber's process? Haber's process means the manufacture of ammonia. Industrially, the manufacture of ammonia from hydrogen and nitrogen. There is a catalyst. What is a catalyst? Iron as a catalyst. Then the temperature is very important, that is 673 Kelvin, and atmosphere is 200 atmosphere. And this happens according to the Le Chatelier's principle. Correct. So this is the reaction with the nitrogen. So this is very important. Okay. This is very important. This you will study, that is the Haber's process. Now the next reaction, the chemical reaction, the fourth reaction is the reaction with the metals. The reaction with the metals. You know, hydrogen plus any metal will give you the corresponding hydrides, that is MH. Here you remember, this will have a -1 oxidation state, hydrides. All other hydrogen you will have a +1 oxidation state, but in hydrides you will have a -1 oxidation state. Okay. Now normally this metal will be, remember, alkali metal. Alkali metal means group 1. That means lithium hydride, then sodium hydride, see, sodium hydride, cesium hydride, etc. So that is the reaction with the metal. So it's clear, the reaction with the metal. Then two more reactions to go, that is the fifth reaction. The fifth reaction is the reaction with the metal ions. What is it? The reaction with the metal ions. So the sixth reaction is the reaction with the metal ions and metal oxide. See, the reaction with the metal ions or metal oxide. That means, see, hydrogen plus metal ion, for example, if you say a heavy metal ion like palladium ion, then it will reduction takes place. That is addition of electrons to form palladium plus this H plus. See, the palladium will be a solid, this hydrogen is a gas, and the ion is in aqueous. So, this reduces the metal ions in aqueous solution. Okay, so this is the reaction with the metal ion. And if you say metal oxide, for example, MXOY, this metal oxide, it will also reduces to the corresponding metal plus H2O, YH2O. See, XM plus Y. So mainly here what happens? Mainly here the reduction happens. Just remember that. Mainly the reduction happens in this case. Okay, so this is about the reactions with the hydrogen. Okay, now one more reaction is there. The reaction is actually the reaction with the organic compounds. The reaction with the organic compounds. See, for example, when first is you have studied the hydrogenation of vegetable oils using nickel as a catalyst. You have studied that, isn't it? That is hydrogen plus CH2 double bond CH2. You will give you CH3 single bond CH3, isn't it? For saturation. Saturation is happening. Okay. So this is an example of the organic compounds reactions. Second is, this is a hydrogenation. Second is hydroformylation of olefins yield aldehydes which further undergo reduction to give alcohols. That means, see, this hydrogen plus carbon monoxide plus any alkene, for example CH2 double bond CH2, will give you an aldehyde. This will you will study in the organic chemistry more. That is CH3, CH2, then CH2, CHO. See, CH3, CH2, CH2, CHO. Okay, so 1, 2, 3. Sorry, this won't come. There is only 3 carbon atoms, right? So CH3, CH2, CHO. CH3, CH2, CHO. Okay. Now this aldehyde will reduce to give alcohol. That is CH3, CH2, CH2, OH. So again, this is the reaction with the hydrogen with the organic compounds. First is hydrogenation and second is hydroformylation. This is called as hydroformylation. Hydroformylation, that means hydrogen and CO. Okay, so this is the reaction. So first we reaction with halogens to form hydrogen halide. Second is with oxygen to form water. Third is with nitrogen to form ammonia. Fourth with metals to form metal hydrides. Fifth is ions, metal ions. Reduction happens to form the metals. Then with organic compounds. Okay, and the last in this hydrogen is the uses of hydrogen. There are so many uses of hydrogen. Just you have to learn 2 or 3 useful. Okay, so you know first hydrogen is used as in the manufacture of ammonia. That is a very important use, the manufacture of ammonia. Okay, it is a very with that the process is called as Haber's process. So manufacture of ammonia, the first use of hydrogen. Correct. So this is of ammonia. Okay, and this ammonia is in turn used in the manufacture synthesis of nitric acid and nitrogen fertilizers. Very important. Okay, so that is the first use, nitrogen fertilizer. Second use is this hydrogen is used in the manufacture of vanaspati fat or simply fat. Vanaspati fat by the hydrogenation of unsaturated vegetable oils. Okay. Then third is it is used in the manufacture of metal hydrides. We have studied. We have seen this reaction, metal hydrides. Okay. Now the fourth reaction is it is used in the preparation of hydrochloric acid. In the lab you can see the hydrochloric acid, isn't it? Okay. So many preparations are there. We will write some more. Then it is used in the preparation of rocket fuels, hydrogen is used in the preparation of rocket fuels in space research. Okay, and the very important use is it is used in fuel cells. Very important. Okay, it is used in the fuel cells for generating electrical energy. Okay, so these are some of the uses of hydrogen, just to keep in mind. Okay, so this is all about the hydrogen. Okay, so the next class we will talk about the hydrides in detail. So till then, thank you.